Hello and welcome back to part 2. So yeah, in the last episode, no, in the last tutorial, we ended up just quickly throwing in some depth here for the edge detection. So I'll just comment this and I'll just call that edge. And so the first thing that I'm going to take a look at is the normal map for two reasons. One, it's not moving at the moment, and the other one is if I select this. At the moment, if we wanted to give this like a different kind of tiling, you know, like something random like 2.3, then we would get some seams basically. If I can just find an area. So yeah, it's kind of hard to see, which I guess is good, but there is a noticeable seam here because although the texture itself tiles, if you're trying to tile it by sort of strange numbers, like if you just want it to be like a little bit smaller or a little bit larger, you're going to get those seams like right down there. So yeah, we're going to just move on to those. So for now, what I'm going to do is let's actually just get this bigger. That's one thing I never do. So let's unhook this normal map and we'll bring this guy somewhere where we're going to have a lot of space because this is going to be quite a big one. So first of all, we're going to bring in a texture object, and the reason that we're going to bring in a texture object is we're going to actually have two of these normal maps, but we want them to use the same texture. So if we do this and that, then whatever we throw into this one here, which will actually be our normal map, which will be exposed on the actual material, then it will propagate it to both of these. So we can have two different controls, which is handy because we want to pan one in one direction and we want to pan the other in another, and we also want to kind of mess with the scales, so we can do that now because we have two of them. And so yeah, to get rid of that tiling issue, we've already made in the previous episode the world space UVs, and we registered it here to a world space tile. So let's just go ahead and we will get by holding down the G key, or if you just search get, it'll be there. And we want the world space tile. And what we're going to do is we're going to multiply this by a value. So we'll say normal tile. That'll do. And then those will be the UVs. For now, actually no, not for now. Let's try and do this right. Like normally I try to do stuff, show you why it's wrong, and then try to fix it, but this is one of those instances where that's it's not really necessary. So instead what I'm going to do is get down another multiply, and we'll hook this one onto that, and then we'll multiply this by 5 or so probably. No, I've already made a mistake. Great start. We want to multiply this value and then feed it through this one. In fact, actually what I was doing before probably would have worked. I might test that afterwards, but for now we'll just leave it at that. So basically what's going to happen here, we'll multiply this by say 5. This normal tile amount, which will specify it, let's say 1 for now, which might be kind of way too huge. This will be the tile amount for the first normal map, and then we're going to multiply that number by 5 for the other normal map, so it has a different UV scale, which is, you know, pretty cool. But because we do want these to pan, let's get ourselves a panner node, and we'll just copy that. And I'm not sure if I mentioned it before, but someone in the comments did let me know that if you hold down Alt while you move a node and then drag it over a line, it will just automatically connect it like that. So it's pretty cool. So yeah, we'll do that for the UVs here. So this is going to run through the panner before it gets to the actual normal map, which is pretty cool. But now we just need to kind of put in some stuff here for the actual the speed, so the actual panning itself. So we'll get a vector 2, and this will be the pan direction. So it will be which way we want the pan to go. So we'll feed that into the speed, and for this one, let's just say it's 1 on the X. We might need to change this afterwards, and then we're going to duplicate this pan direction, and we'll just call this pan D2. And so this will be the opposite way, so -1 in the x, and we'll feed that into speed. Okay, great. So now we just need to kind of solve the time, because it needs to kind of move along with the speed rather than just a direction. So we can introduce a multiply, and we can stick that 4 there, so it goes pan direction into the multiply into speed, but then we'll multiply the direction of this by the speed that we wanted to move at. And I'm sorry if this is kind of sounding a bit confusing. I may be going a little bit quick because I want to get this done in like this one episode. I keep saying episode, these aren't season things, but yeah. So yeah, I apologize if I do kind of run things a little bit too quickly, but it's kind of the way it is right now. So I'm multiplying this normal speed again just to come down here, because we can actually introduce a different value. So similar to this mess that we'd made over here, we can multiply our other pan direction, and then we'll hook these two multiplies up. So what will happen, I also need to change this multiply here to a different number, because, well, I mean, otherwise there would be no point in using it. So basically what we've just done here is we've got the direction that we want the normal map to move in, and we're multiplying that by the speed that we want it to move. So let's say a default of 1, and that's fine for this one panner. But then as we kind of come down, what's happening is that speed is getting multiplied by 3 for the other panner, and the pan direction is being inverted. So it's just going to move in a crisscross way. There are other ways to do this. This is just kind of the way that I have done it. So yeah. Oh, sorry, I have some issue with my mouse where it clicks twice for some reason. It's pretty annoying. So yeah, after all of that, we are now ready to finally add these two together. So we can blend these normals, and we'll do this, do that. Actually, one last thing we'll do, because I did mention before, it is nice to control the scale. So I'll say a normal strength on this new vector 1. We'll make it a slider and a default value of 1, and we'll hook that into the scale here. So we have that blend normals going out. So now let's register this, and we'll just call this normals. That's what we'll call it. And then we'll grab all of this mess, give that a comment, just say normal map. And so now we can come down here to our normals, we can get a get, and we'll say normals. And then we'll hook this in, hit apply on that, and then let's just see where I've made a mistake. Okay, so looking at this, something immediately kind of seems a bit iffy. It's because now we don't have the normal map texture there because we introduced a new node. So I'll just grab my water, and so we have we don't have any of the properties that I made. I guess I didn't make those into actual properties. So oops, let's go back here, normal speed. So yeah, I'm just going to turn these into properties. Okay, now we actually have some stuff happening, but it is kind of crazy, pretty fast moving. That looks pretty trippy. 0.03 maybe, or maybe not even 0.01. Yeah, so these numbers are kind of crazy, but what you can do for that, let me just get a slightly better angle there. But yeah, I mean, it's kind of looking nice. You have that that glint, but yeah, if you don't want these like ridiculously low numbers to work with, then what you can actually do, and you know, this is going to create a little bit of a mess here, but because at the moment we're just multiplying this by a number, and so if we were to drop down a divide, so we'll divide this first by let's just say a number, and we'll give it I don't know, a value of say 2 or something, and we'll put that in there, and now we'll run that through the multiply, which is the one that's hooked up to yeah, I know, kind of messy, which is the one that's hooked up to the actual normal tile, which basically means we are already kind of affecting the number before we affect the number. So yeah, you know, it's pretty messy. And because we've introduced this here, we don't need this multiply running down here. We can actually just hook this divide straight into there. So, you know, it's a bit of a symmetrical split here. So let's, I'm also going to just increase this to maybe 10. So this number, the actual UV number that we were working with before, we are basically dividing that by 10 before it enters the property that we have exposed. So it doesn't actually change anything except for the fact that now we probably don't have to deal with ridiculous, like tiny little numbers. So now like a tiling of 1 is actually kind of okay, whereas before a tiling of 1 was, you know, was kind of insane. So yeah, it's pretty cool. So yeah, kind of tweak this to whatever you want. I'll probably leave it about there. And you can do the same thing for the speed. For me, I'll probably just leave it there for now rather than extending this tutorial like even further. So yeah, the next thing that we're going to work on will be the like the overall depth, and then we'll also introduce the texture for that, and then the seafoam texture as well, because you know it uses the same thing, so it's all good. So let's just start with the edge foam itself. So let's just move this guy up here because I probably want to build it. I mean, it doesn't matter. But so yeah, we'll start with again, we're going to use a texture object. And the reason it's an object is because, as I said before, we are going to use this texture twice. So we might as well just have one object for it. We'll just call this seafoam, which will also again act as the edge foam, which is what we'll do now. And so that will just be hooked into a regular texture 2D. And yeah, again, we'll kind of grab our world space tiling, world space tile, and let's just, wow, there goes my mouse again. What have I done? There we go. So yeah, we'll multiply this by a value, and this will be our let's see, edge foam tile. Give that a default of 1, and we'll stick that into UVs. And to kind of just reiterate that bit that we did before, actually, because again, we're going to end up with like the tiny numbers rather than this. If I just unhook that for a second, if I just bring in a divide, put that in there, and then we'll just get float 1, let's say 10, and then introduce the multiply with the tile. So now this number probably won't be as insane. But yeah, so that's what we'll use. Oh, come on now, mouse. Come on now. I'm recording. So that's what we'll use as the base texture, and we just need to add it actually to the edge that we actually have up here. So let's just get an add node, do that, and what we'll do is we'll just expand this out a bit. Grab these guys, move them over, put that there, and then rather than the 1 minus feeding straight into the multiply, we will feed it into the add, and then that will come up into the multiply. And so now we can kind of just grab this stuff, and we could just call this edge foam. So let's just let's see what that looks like for now. Do that, and then we're going to need to apply our texture. Something tells me also we're going to need a clamp in there somewhere, but okay, we already have one, but let's just make it black to white. Okay, and then let's just grab our seafoam, which again I will be providing. So yeah, there's that, and then we should have the tile, unless, as like usual, I didn't make it a property. Yeah, I really wish it would be a property by default. I am kind of used to that from ShaderForge, but there we go. So yeah, there's our tiling amount, so we can have big, or we can have, you know, small. We should have somewhere here, I guess it was much higher up, the edge distance, so this, you know, controls sort of how much is there. And because we've added the foam texture after the bit where we have the actual depth, and we do the 1 minus, we do still end up with the actual original like just this white line that was there before. You can elect to kind of not have that and to only have the foam texture, but personally I kind of prefer it this way because it keeps it makes it feel like it has like a much sort of stronger edge. So yeah, that's why I keep that in there. Okay, so moving on, that seems to work okay. In my preview ocean shader that I showed in the beginning of the first video, I did also have two of these textures, and they were panning around, and you could adjust the size. I won't cover that in this tutorial, only because it's the exact same method as here. So as far as a teaching perspective is concerned, that's already done. Like if you wanted to have foam kind of panning and then have another one overlapping in an opposite way, then yeah, it's exactly the same as what we've just done with the normal map. So yeah, don't have to worry about that. So let's move on to the actual sea foam. So because we already have this texture object up here, which we use for the edge foam, let's just drop down another texture sample, and we'll just steal this guy. And again, for the UVs, we'll just get the world space tile. And again, I mean, we might as well just kind of copy some of this stuff. So bada bing, bada boom. So it's the same kind of setup. So we divide by a number, and then we multiply it by the actual tiling amount. So we'll say seafoam tile for this one, automatically a property, which is good. And we'll feed that into the UVs. And then that's kind of it. We are going to do some extra stuff, but for now, let's just create a register, and we'll just call this one seafoam. So yeah, we don't have much to do with this right now, because we will be attaching it onto the albedo, but it needs to get masked out. So let's just give ourselves some of this, give ourselves a little bit more room. But yeah, essentially all we want to do, because at the moment we're using this lerp, which is based on the wave pattern that we've created. So there's the watercolor and then the top of the wave color. So we just want to actually add like onto the top of the wave color the sea foam that we've just created. So sea foam, and we'll stick that in there, and then this becomes the new B input. But it's going to be well, I'll show you. So it's going to kind of like plaster it like all over the place. So let's have a look at this. So yeah, now we have this. So you know, it's always there, and it's kind of always constant. It's still, you know, if you were having like a stormy sea or something, that would kind of be okay. And again, it is using the world space UVs, so you don't have to worry about it tiling. But yeah, the one thing that I do want to introduce is some kind of like random masking, so it's just not, you know, always appearing kind of in full. And the way that we'll do that is with a noise generator. So we'll just get that noise generator, and we do want this to kind of like move around, like, because if we just use the static noise, then it will always mask out in the exact same place. So we do want this to kind of move around a bit. So we are going to get a panner node, and we'll, oh, come on now, stick that in there. And then obviously, you know, we do need UVs for this, and we might as well just use the actual world space that we have. So again, I'm just going to multiply this by a vector 1, and I'm not going to make this a property. So now if we hook this into the UVs, and let's just have a look at sort of this. Yeah, I'm not going to make it into a property permanently. I am going to do it just for now, because I want to basically grab this noise that we've just made. In fact, I'm going to create a temporary register. I'll just call this foam mask. Get that there, and I'm going to stick this into the debug. So get foam mask. So similar to what we did before when we were trying to work out sort of, you know, how stretched the waves should be. We're going to use the same thing now to try and work out kind of what sort of tiling we want here, and also for the actual panner. In fact, where did it go? There it is. And so for this one, we don't really need to expose like the speed and the time, because this is kind of a background thing. You know, if you're trying to make tweaks to this thing on the actual like final material, it will be like near impossible to tell what numbers are actually changing anything, which is why it's kind of good just to set it up now whilst you can kind of see it, and then just change it after the fact. So yeah, we'll get something like this. It doesn't really matter kind of how it moves. The only thing that matters is the speed, because you don't want it to be too fast, because then it would just kind of, you know, it will look like your foam is kind of having an epileptic fit. But at the same time, you don't want to be too slow, because then, you know, it will seem like your foam is still appearing in the exact same places. But yeah, I'll go maybe like 0.1, 0.2, something like that. Although we should probably sort out the actual tiling first. So yeah, you do want it to be kind of big, because then you get these nice areas where the foam exists and then other areas where it won't. So I am going to actually bring down the speed again, so 0, 0, 0.03 maybe. And again, you don't have to use these exact same values. So yeah, I've ended up with a 0.03, so I'm going to punch that into this as the default, and I will put that as a constant. Now I can get rid of this from the debug, and I can actually just remove it entirely because we didn't actually need it. So yeah, now let's come back up in here. So now we have our noise, so we just want to actually multiply the texture that we had, and I'll only use the red channel because it is just a black and white texture. So yeah, we'll multiply that with the noise that we just made, and we're going to want to clamp this out because it is kind of overlapping stuff, and then that is what feeds into there. And so now so this is already using that reference that we made, but this should be pretty good to go. So let's just, so yeah, so let's just have a look at what this is actually doing. Okay, so as you can see here, we get the foam, and then at some points you see we will not have the foam. So it's, you know, it's kind of random, but it will only ever appear on the top of a wave, but it won't always appear. So yeah, it's pretty good. And again, like this is one of those things, like you should probably just tweak this to whatever you want. Okay, so now we are going to work on the depth, and with the depth also comes the refraction. In fact, so let's just let's bring this up bigger. Let's just get all the stuff that we need for the actual refraction. And the way that Amplify does this is you first you grab the screen position, you run this through a component mask, and I don't know if you need to leave all of these on or not. The way that I've always done it in the past through ShaderForge is like we would only need the red and the green channels. In this case, it would be X and Y. But you know, I'm not entirely sure if that actually makes a difference, like if you use all of them or not. But either way, the refraction works fine. So yeah, we'll get a vector 1, make this a property. Just call this refract amount, and then we're going to multiply this. Also, we'll give it a default value, and I would recommend to start kind of low, so 0.1, and we're going to get our normals. There they are, normals. So this is the combined normal map that we have, yeah, after all of this panning stuff. So that's what that is. Yeah, and then we'll add these two together, because basically we want to refract based on the normals, and then we want to be able to control the strength of that refraction. So after you do that, you want to grab the screen color. So again, we'll grab screen color, and that is it basically. I would throw in a clamp, and yeah, that's it. So now we're going to register this as refraction. And yeah, as I kind of said before, there's not much we can do with this right now. Like if I were to just like make an absolute mess here and not register, if I were to get the refraction, and then let's just stick that in the albedo, and let's see what that looks like. I mean, obviously it's pretty weird. I wonder, did my clamp has it gone onto the red range? It has. I'm not sure why it does that. So we'll put that onto the white range anyway. So yeah, that's better. So at least, I mean, from here, I guess the only thing to test is the actual refraction amount. And yeah, you do probably want it pretty low, like 0.03 or something. But you can see this is one of those instances where it refracts just everything. So this shark right now, like his outline, you know, he's being refracted even though he's not in the water. And this is not a problem that's easily fixable. But we can introduce the depth of the water and use that to kind of mask out the refractions. Let's just build all of that, and well, first of all, let's put the albedo back. So we'll get rid of that for now, because yeah, at the moment we have refraction. In fact, let me just comment that, but it's not yet ready to join the albedo. So refraction. Yeah, okay, I thought I spelled that wrong. So yeah, very similar to the edge stuff that we have over here. What we want to do is introduce another depth fade, and then we'll actually just get this one and we'll just call it depth. Put that into the distance, and then I'll put like -4, because I know from the previous one that I built that -4 was about the number that worked well. And we're not going to use a 1- on this. Instead, let's just throw in a clamp. And then there is some other stuff that we can do, but for now, let's just throw this straight into a register, and we'll just call this depth. And so at this point, actually, we are now ready to kind of test the refraction out. So what I'm going to do is I'm going to get my albedo here, and I'm going to get a lerp, and I'm going to lerp my, let's see, get my refraction, which will be B, so my albedo will be the A, and we're going to use the depth that we just made. So let's get depth as the alpha for that, and yeah, you'll see kind of what it, I mean, it will look okay, but I'll show you. Okay, so we have this, and did I not make the depth a property? There we go. Yeah, and so now, okay, so we do have the depth. Maybe I did need to introduce that 1- actually. I could have sworn that I didn't, but I mean, this is a gargantuan shader, so you can forgive my memory for sometimes getting a bit iffy, I hope. So yeah, let's just get down the 1-, stick that in there, and then if we hit apply on that now, okay, yeah, there we go. So that seems to have done the job nicely. So now we have, you know, you can have it super murky or super clear. And before, as I was sort of demonstrating with the shark, he's no longer refracting because there isn't enough depth in front of him to actually refract. Whereas if we were to kind of get really clear water, then he will start to refract. But yeah, otherwise no. So yeah, as I said, this does kind of fix the issue, and at the same time kind of doesn't, because for example, you can see this rock here where it meets the shore, and we can still kind of see through the water. It will refract on the outside, but as the water starts to get deeper, there's no refraction. So yeah, that's pretty cool. So let's just get this, make a comment, and we'll just call this the depth. Okay, and so that is almost there. We just need to, I mean, this is, wow, this is kind of a mess. We just need to upgrade our tessellation a bit. They actually have their own distance-based tessellation, so yeah, we don't need to worry about that. So let's just unhook tessellation here, and we'll stick that into there. And then minimum distance and maximum distance. Now this obviously depends on like the scale of your scene. So for me, I'll probably have so min will be 0. So this is like the distance away from the camera. So yeah, I want to keep that very much at 0, and then I'll bump this up to say maybe 80 to be the maximum. And then we still keep our initial tessellation, so let's just kind of hook that into there and then give that a save, and then let's see what that looks like. Okay, yeah, so you can see off in the distance low poly, and then down here pretty high poly. So the only thing that's missing, if I come down here to ocean, if you remember from the first video, in fact let me keep that on, when I adjusted the height of the waves, it would actually, wow, okay, that's crazy. It would actually update the tessellation as well, whereas in this case, it's not actually happening. So everything kind of stays the same, which is fine because I have actually quite a high tessellation value here anyway. But ordinarily, like for these sort of flat waves, you wouldn't want them to be, you know, like there's no need to have all of this geometry here. And so what we need to do is basically just multiply this value that we have with a value that already exists, which is the wave height. So yeah, let's just let's unhook this for now because I want to move this, and we'll actually just get another register here. So yeah, as I was saying, we need to grab our wave height, which is this one, and we just need to multiply this basically with the tessellation number that we already have. And so that will be the new factor. So now let's go and check it out. So yeah, immediately we've kind of lost some geometry, which is cool. And then obviously the further away you get, you will get that low polyness. But then if I start to increase my wave height, all of that geometry starts to come back in. So yeah, pretty cool. Yeah, and I think, unless I'm forgetting something, so we've done refraction, which is hooked into the albedo, based on the depth, the edge foam, sea foam, wall space UVs, wave height, wave pan, tessellation. I think that's everything. Obviously, you know, feel free to expand on this. Like a lot of people do, like their watercolors with a Fresnel, and there's, you know, no reason that you couldn't introduce this among all of that. You just kind of have to have other sort of lerps or adds or multiply those things in. So yeah, let's just give this one final save. We'll close it down, and yeah, I will call that tutorial done. So thank you very much for watching. You know, I hope you learned something. I apologize if I kind of ran through a lot of this stuff a bit too quickly. There was, you know, a lot of information kind of condensed down into my brain that I just had to kind of get out before I forgot it all. But yeah, if anyone has any ideas for improvements, or, you know, things that they would do differently, I am kind of all ears. As I mentioned in the start of this tutorial, there's no underwater stuff, there's no actual like water interaction, so yeah, it is just the water as you see it now. Oh, actually the last thing I did forget was to make this two-sided, but if I just open up this, we can just somewhere in here, yeah, the cull mode, just set that to off, and you only need to do this if you actually plan on doing something kind of underwater. But yeah, and the nice thing about this is that the like it's basically just a reverse thing of what we already have, so you can still see sort of up, and you know, there's that shark dude there and he's refracting. So yeah, it's pretty cool. Definitely, you know, could do with some expansions and some improvements, but yeah, for now this is done. So again, even though I already said it, thank you very much for watching. Yeah, I will see you in the next one.